The main applications of dimension analysis, the first one is to check the correctness of an equation. The second one is to derive a physical relation or derive an equation. And third one is to convert a particular physical quantity from one system of unit into another unit. Suppose from SI unit into CGS system, Newton is the unit of force in SI system, dyne is the unit of force in CGS system. So if you want to convert Newton into dyne, the conversion we can do with the help of dimensional analysis. Okay. The first application of dimensional analysis is to check the correctness of an equation. Suppose you are deriving a new equation, physically whether it is correct or not. You can use the help of dimensional analysis. Suppose for example, you derived an equation, kinetic energy is equal to half mv square. Okay. This equation will be correct if dimension of both the sides is same. You apply the dimension of mass. What is the dimension of mass?
M, capital M, sir.
Capital M. And what is the dimension of velocity?
Length and t minus 1.
L t raised to minus 1, square of that.
Yes.
V square is there. So the right hand side dimension is m into L square t raised to minus 1 into 2 is minus 2. ml square t raised to minus 2. That is the dimension of right hand side. Now kinetic energy, you know, energy means work done. Energy is the capacity to do work. So dimension of energy means, kinetic energy means dimension of work only. Work and energy are same, both are in joule. What is the unit of work?
Joule.
Joule. What is joule? Newton into meter. What is Newton? Force, ml t raised to
Minus 2.
minus 2 into meter.
Minus 2.
Into meter, ml square t raised
square
to.
t raised to minus 2.
Now you see the dimension of both sides, LHS and RHS. This is the dimension of left hand side of the equation, LHS of the equation, and this is the dimension of RHS of the equation, and both the case ml square t raised to minus 2. So it is correct. And also if you take an equation like this, suppose there are more than one term in an equation. For example, you remember the equations of motion you studied in 9th standard, V equal to U plus AT. And
Yes,
this
sir.
equation will be correct only if the dimension of each term on either side of the equation is same. Each term, for example, dimension of this V should be equal to dimension of U should be equal to dimension of AT. There are two terms at the right side, one is U, other is AT. Each term should have same dimension at the LHS and RHS. Then only this equation will be correct equation. Got it? You
Yes,
know
sir.
what is the dimension of velocity? U also initial velocity, that also LT raised to
L t raised to
minus
minus
1.
1.
AT dimension we can write
Yeah.
acceleration is LT raised to minus 2
Into
into
t.
time is only t. So t raised to
LT
1
raised
and
to
minus
minus
2 cancel, become LT raised to minus 1. So we have same dimension for this LHS and RHS, the first term and second term, all are same dimension. So it is dimensionally correct. K is equal to half mv square. Okay, and we found it is correct. Now Fahim also at the same time from another class, he also derived equation for kinetic energy. Okay, he derived the equation K is equal to just mv square. Then check the correctness. He is checking the correctness of the equation. RHS mv square. M is capital M, mass dimension is capital M, velocity square is LT raised to minus 1 square. So that will be L square t raised to minus 2, L square t raised to minus 2. This is the dimension of the right hand side, RHS mv square, this dimension. Okay, and kinetic energy dimension, energy means work done is converted to energy. Work equal to force into displacement. Okay, that is force is ml t raised to minus 2 into L. So that L will come here, so we can write ml square t raised to minus 2. So here also the dimension ml square t raised to minus 2 of the RHS and ml square t raised to minus 2 of the LHS, both are same, isn't it? But is it a correct equation?
No, sir.
Equation, it is a wrong equation. This is the point here. An equation dimensionally correct may or may not be a correct equation. An equation dimensionally correct may or may not be correct equation. But if it is a dimensionally wrong equation, means it is wrong equation itself. So we use the word now onwards dimensionally correct. And if dimensionally correct equation may or may not be correct equation. But if it is dimensionally wrong means wrong equation only. Now in this equation, v equal to u plus at to be
Yes, sir.
correct equation, dimensionally correct equation, dimension of each term should be same. Each term should have same dimension. The dimension of v, dimension of u, dimension of at should be same. Principle of homogeneity of dimensions. This principle is called principle of homogeneity of dimension. Okay, then write down these three equations as homework. Check the correctness of these three equations. This is homework for you. Okay, do it. Thank you.